Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 22, Building the Future of Manufacturing with Modern Technologies. IoT, digital twins, and AI aren't just futuristic buzzwords, they're the core of today's competitive advantage. In this episode, we explore how smart factories use these technologies to move from reactive management to real-time decision-making and proactive transformation. You'll hear how DBR77 integrates sensors, simulations, and intelligent analytics into one powerful platform, helping companies cut costs, boost quality, and scale with confidence. This isn't just about optimization, it's about building the future step by step. Factory on Air is powered by DBR77, the platform that turns data into decisions and decisions into industrial transformation. Let's get started.
Welcome back to the Deep Dive. Today, we're really getting into the architecture of, well, what makes modern industry tick? Or perhaps, what should make it tick faster?
That's right. We're moving beyond just tweaking things, aren't we?
Exactly. Forget slow optimization. We're talking about a fundamental shift, tearing down some old ways of thinking and building for real-time adaptation right now.
It feels like a really critical moment. I mean, our sources, they all point to this. For years, companies saw things like AI, maybe the digital twin, as future stuff, optional.
Down the road technology.
Precisely. But that window, it seems to have slammed shut. Nowadays, this kind of digital integration, it's table stakes. It's about survival, staying competitive globally.
And the old ways just aren't cutting it.
They really can't. Traditional operations, they're built on planning that reacts slowly. You're always behind the curve. It just can't keep up with how fast markets change or, frankly, the rising costs of just doing business.
Okay, so let's unpack that, this necessary transition. Our mission here today is to look at how companies, how you listening, can move past those old limits. We're focusing on integrating three core technologies. IoT, the Internet of Things for the raw data.
The foundation.
Then the digital twin for simulation for testing.
The virtual proving ground.
And finally, AI, artificial intelligence, for the smarts, the interpretation. We're really trying to pull out the core assumptions driving this big digital shift.
And the central problem we're trying to solve, the thing everyone's grappling with, is that the old way of running production is just fundamentally reactive. It has to be.
How so?
Well, it's built on plans that only kick in after something's happened. You know, a bottleneck forms, quality dips, a machine goes down. But you only find out after the data lag tells you the bad news.
So you're always looking backward, always playing catch-up.
Always. And that means built-in inefficiency, costs hidden in delays, and ultimately losing your competitive edge because you just can't react fast enough.
Right. And this is where the new paradigm, the modern approach, really offers a different path. The research we've seen stresses this point again and again. Success isn't just about being bigger anymore.
No, sheer size isn't the advantage it once was.
It's about having a much greater capacity for adaptation. That's the key word, isn't it?
Absolutely. Adaptation. Flexibility, agility.
And we're going to dig into how a unified platform architecture, bringing these technologies together, is really the bedrock for making that kind of instant flexibility and foresight possible.
And that capacity for adaptation, it isn't just some fancy buzzword. It's really the strategic ability to survive, to minimize risk, and, to keep growing in what's become a really unpredictable global market.
Okay, let's try and paint a clearer picture. What does this shift actually look like on the ground? When we talk about moving from reactive to proactive management, how different does the factory floor or maybe the warehouse feel?
Well, the difference is stark. It really all comes down to data visibility and, crucially, the speed of decision-making. Traditional systems, they're basically prisoners of delayed reporting. You get reports maybe today, maybe tomorrow about yesterday's production losses or quality issues or supply chain hiccups.
After someone's had time to crunch the numbers in a spreadsheet.
Exactly. After managers have manually collated everything and run some analysis, which means, by definition, any decision you make is trying to fix a problem that's already happened. It's already cost you something.
You're always stuck looking in the rearview mirror.
That's a perfect analogy. Now contrast that with the modern approach. Here, decisions are based on data that's captured, processed, and analyzed in essentially real time.
Instantly.
Pretty much. And this level of immediate visibility, it unlocks things like automated material flows, automated information flows. You get complete transparency across every single process.
And we're not just talking about a fancy dashboard, right?
Oh, no, it's much deeper than that. It's a unified stream of information. Think of it coming from the sensors on every machine, every device on the floor, flowing all the way up seamlessly to the management dashboards in the boardroom. Total visibility.
And that real-time transparency, it must completely change how you compete. I mean, the sources we looked at were really strong on this point.
Yeah.
Market advantage isn't just about churning out the most stuff anymore.
No, it's shifted. It's about who can adapt the quickest, who can respond fastest to a sudden change in, say, global demand, or a spike in material costs, or maybe new regulations.
Right.
Think about what that means operationally. If you can implement a major change on a production line in, say, minutes instead of days,
Wow.
or scale your capacity almost instantly because demand just surged, or maybe steer clear of a bottleneck that's just starting to form before it even slows things down, that gives you a huge strategic advantage.
The big goal, the overarching aim of this whole transformation.
It's that fundamental shift, moving away from just reacting to problems you can finally see towards truly proactively managing, predicting, and optimizing the entire flow of production and logistics.
In getting to that proactive state, it hinges completely on integrating those three key pillars we mentioned earlier, doesn't it? IoT, digital twin, AI. Let's break down what each one actually does in this combined system.
Okay, absolutely. So you have to start at the foundation. That's the Internet of Things, the IoT. Think of it as the data layer. It's like the nervous system of the entire facility.
Okay.
Its main job is to supply that raw, unfiltered, very granular stream of data from every important point. We're talking sensors on motors, controllers, maybe RFID tags, tracking parts, connected tools, even the movement of people or assets like forklifts or AGVs.
So everything that moves or operates.
Pretty much anything relevant.
Yeah.
And the key point here is without a constant stream of reliable, accurate, and importantly structured IoT data, well, none of the clever stuff on top can actually work. The AI, the digital twin, they're starved without it.
Got it. So IoT delivers the facts, the high-res picture of what is happening right now. Okay, next up is the digital twin. Now, this concept can sound a bit abstract sometimes. What's its real practical job in this setup?
Yeah, it's easy to think of it just as a cool 3D visual, but it's so much more. A true digital twin is a virtual, high-fidelity, and critically, a mathematical copy of your physical processes.
Mathematical.
Yes. That means it has accurate, physics-based models baked in. It uses sophisticated techniques like discrete event simulation, or DES, to perfectly mirror how things actually behave, the timing, the constraints, the interactions across an entire production line, or maybe a complex distribution center.
So the real power isn't the visual, it's the simulation capability.
Exactly. That's the core function. It lets you monitor what's happening, sure, but more importantly, lets you analyze and optimize different what-if scenarios without ever touching or risking your live production.
Okay, like a virtual sandbox.
Precisely. You can see exactly what impact changing the layout might have. You can test out new scheduling logic. You could even predict the long-term wear on a specific machine part, all in this safe, cost-free, risk-free virtual space.
That simulation part feels key. It gives you foresight. It's the tool for planning improvements, reducing costs, boosting efficiency, without the usual trial and error pain.
It absolutely is. It's the differentiator. It lets you see the future consequences of your decisions today.
Okay, that's huge. Being able to predict the outcome before you commit money or suffer downtime. Massive. But this virtual lab, it generates a lot of possibilities. It needs an interpreter, right? Which brings us neatly to the third pillar, artificial intelligence.
Right. AI is the intelligence layer. Its fundamental job is to make sense of that huge, relentless flood of data coming from the IoT layer, often contextualized or tested within the digital twins models. AI provides the foresight and, crucially, the actionable recommendations.
How does that translate into value on the shop floor? What does the AI actually do?
Well, AI works on a few levels here. First, it's brilliant at detecting anomalies. Tiny, subtle deviations from the norm that might signal impending trouble. Things a human might easily miss.
Like a machine vibrating slightly differently.
Exactly, or recognizing really complex, non-obvious patterns in the data that humans, even experienced ones looking at dashboards, might not spot for hours, maybe even days. But critically, AI goes beyond just spotting problems. It provides prescriptive recommendations.
Meaning it tells you what to do.
Yes. For instance, it might pick up the acoustic signature of a bearing starting to fail and suggest specific maintenance before it breaks. Or it could spot a tiny temperature drift that, based on patterns, will lead to a quality issue in, say, 30 minutes, and then automatically adjust a machine setting to prevent it.
Wow. So it's seeing problems develop before they're obvious.
Often, yes. It frequently detects a potential issue and recommends a fix before the human operators even realize something is starting to go wrong. This is what enables that shift from reactive or even just scheduled maintenance to truly predictive maintenance.
Okay, so let's tie that together. IoT provides the real-time data feed.
The facts on the ground.
The digital twin provides the virtual laboratory to test what-ifs based on those facts.
The consequence engine.
And the AI provides the intelligence to interpret it all, spot future problems, and recommend actions.
That's the synthesis, exactly. When you bring these three together effectively, they don't just support production anymore. They merge into this intelligent, constantly learning system that actively leads and guides the facility. It's providing continuous forward-looking guidance.
Okay, this integration sounds incredibly powerful, but it also surfaces a pretty major architectural challenge, doesn't it? Now, one thing to buy these cool technologies, IoT sensors, digital twin software, AI algorithms, it's a whole different ballgame making them actually talk to each other smoothly.
Yes, the integration headache.
How do you stop them becoming just three really expensive, isolated silos of tech that don't cooperate? This must be where that idea of an integrated platform architecture becomes absolutely essential.
It is. That's probably the most critical architectural insight for anyone listening. Fragmentation is the absolute enemy of successful digital transformation. You see so many companies try to kind of stitch together different best-of-breed solutions from various vendors.
Using APIs and middleware.
Exactly. Lots of complex application programming interfaces, middleware layers, and inevitably it leads to problems. Data latency delays in information transfer, translation errors between systems because they speak different languages, APIs breaking or becoming outdated, and just massive overhead in simply maintaining all those connections.
So the system spends half its energy just trying to talk to itself, basically.
Pretty much. It's inefficient and brittle. A truly comprehensive industrial platform has to solve this by design. By unifying these core components, IoT data collection, the advanced simulation engine for the digital twin, the AI modules for prediction and optimization, and the real-time dashboards into a single cohesive environment. A single technology stack.
And why is that single stack approach so much better from an implementation and operational standpoint? What's the big advantage?
It boils down to simplicity, speed, and reliability. When everything just works together natively within one unified environment, you bypass all that massive complexity, the extra cost, and the inherent risk of managing multiple vendors and paying expensive third-party integrators to try and force-fit systems together.
Sounds like it saves a lot of hassle.
It does. It fundamentally speeds up the whole implementation timeline. It reduces the total cost of ownership because you're minimizing that integration effort. And crucially, it helps ensure data integrity because the information doesn't have to keep getting translated or passed between different systems. It turns what could easily become a multi-year integration nightmare into a much more manageable, strategic, phased rollout.
Okay, let's translate that integration into real-world value. If a facility manages to achieve this kind of digital maturity, this unified architecture, what are the key operational benefits they can expect to see? What really changes for the better?
Well, the data we've seen points consistently to 4 major practical benefits that really drive competitiveness. First, and maybe most obviously, you see significantly reduced operational costs.
How so?
It's mainly driven by much better real-time utilization of all your resources, materials, energy, machinery, even personnel. Less waste, better allocation.
Makes sense. What's second?
Second is a massive increase in predictability. This translates directly into a drastically lower risk of those unexpected downtimes, those sudden production stoppages that can cripple output and kill profits.
Okay. Reduced costs, better predictability. The third one must link back to that core theme we keep hitting on, scalability and agility.
Yes, exactly. The unified architecture gives you the agility to make changes much faster, to scale your operations up or even down much more efficiently when the market signals change. It allows the organization to finally become truly adaptive, truly responsive.
And the fourth key benefit.
Finally, we consistently see dramatic improvements in quality and reaction time, better product quality because you have tighter proactive control over the process variables, and a much quicker reaction time to new market demands or even specific customer feedback because the whole process is transparent and easier to modify.
Right, let's try and bring this home with some concrete examples.
Yeah.
We need to move beyond the theory and look at the actual results companies are getting when they successfully implement this kind of integrated platform approach.
Yeah.
Some of the metrics are pretty astounding.
They really are. Take planning efficiency, for example. Planning is often one of the slowest, most bureaucratic parts of manufacturing, right?
Lots of meetings, spreadsheets, sign-offs.
Well, we have this great example of a factory that specializes in mechatronic components. They integrated their platform solution with their existing ERP system, that's the Enterprise Resource Planning System, handling core business stuff like inventory, purchasing.
The backbone system.
Exactly. They connected that ERP data with real-time IoT data flowing from the shop floor, all within this unified platform. And the results. They absolutely shattered their old benchmarks for planning changes.
How much faster?
Get this. They shortened the time needed to implement major changes in their production plan, the kind of complex change that usually involves tons of coordination, manual checks across departments, getting approvals. They took that down from a painful 3 days to just 30 minutes.
3 days down to 30 minutes. That's transformative.
It's a fundamental redefinition of operational speed. Just imagine what that 3-day lag used to cost them excess inventory, piling up, labor waiting around for decisions, missed opportunities because they couldn't react quickly. Making that switch to 30 minutes means they can execute really complex scheduling changes within a single shift. It gives them almost instant control.
Incredible. And the impact of just the digital twin technology itself seems clearly measurable, especially in tackling those small hidden losses. You mentioned an automotive plant example.
Yes. In this automotive facility, implementing and actively using the digital twin technology led directly to a documented 22% reduction in micro-downtimes.
And 22% might not sound earth-shattering initially, but micro-downtimes are a big deal, aren't they?
Oh, they're huge. Because micro-downtimes, those little quick unplanned stops and starts, the minor jams, the brief adjustments, they are the silent killer of overall equipment effectiveness, or OEE.
OEE being the measure of how well you're actually using your manufacturing assets.
Precisely. And these microstops are incredibly hard for humans to track manually and diagnose effectively, but they constantly chip away at your OEE score. The digital twin, though, with its real-time high-fidelity modeling, can spot the subtle patterns and interactions that lead to these brief interruptions and often predict or help prevent them before they even happen.
Okay. And finally, let's look at the AI's impact on the actual end product. You had an example from consumer goods.
That's right. A producer of consumer goods implemented AI specifically for continuous analysis of quality data across their various production processes. The result, a 17% decrease in the number of product defects coming off the line.
A 17% reduction in defects. That flows straight to the bottom line, doesn't it?
Absolutely. You're talking direct savings in wasted material, less rework needed, lower warranty claims and costs. And this kind of improvement wasn't achieved by just adding more human inspectors at the end of the line. No, it was achieved because the AI system could interpret incredibly complex correlations between hundreds of different process variables, things like machine temperature, subtle variations in raw material batches, ambient humidity, you name it. It identifies the combination of factors that actually cause the defects. And then it can make real-time prescriptive adjustments to the process controls before the defective product is even fully made. It's proactive quality control at a level humans simply can't replicate manually.
Okay, so we've seen the proof points, the tangible benefits. But moving from understanding the why to actually doing it, well, this level of transformation clearly needs more than just buying some fancy software. It demands a really clear, disciplined strategy, a roadmap.
Absolutely. Without a structured approach, you're just throwing technology at problems, hoping something sticks. That's a recipe for expensive failure. You need a methodology to guide the process, minimize the implementation risks, and crucially, ensure that whatever digital capabilities you build are always laser-focused on the biggest business priorities.
And the sources we looked at describe such a methodology.
Yes. They detail an approach often called the Digital Development Roadmap, or DRD for short. The first thing this process does is support companies in properly assessing their current digital maturity. Where are they really starting from? Where are the biggest data gaps? Where are the most significant process losses? What are the existing technological shortcomings?
So it's like a really thorough, honest audit of the present state before you even think about the future.
Precisely.
Yeah.
You need that baseline. Then, once you understand the current state, the DRD process involves analyzing relevant market megatrends. What are competitors doing? Where is the industry heading? What technologies are becoming critical?
Okay.
And it uses that analysis, the internal assessment plus the external view, to create detailed, actionable implementation plans. The research notes this strategy provides essential transparency for management across, get this, over 27 operational, developmental, and technological areas.
27 areas.
Mm-hmm.
That sounds incredibly comprehensive.
Yeah.
Can you give us a flavor of the scope? What kind of areas are we talking about?
Sure. It covers a really wide range, everything from deep tactical issues like optimizing real-time energy consumption or refining quality control feedback loops, all the way up to highly strategic areas like planning your future workforce needs based on upcoming automation, or optimizing how you collaborate with suppliers in your supply chain, or even managing the entire life cycle of your production assets more effectively. By touching on all these different facets, the DRD ensures that your digital goals aren't happening in a vacuum. They get fully integrated into the company's overall business objectives. It gives management a clear, phased plan for how to execute this transformation.
Okay, so let's say a facility leader is listening and thinking, right, we need to do this. If they decide to embark on this journey today, what are the practical, maybe step-by-step actions recommended? Because as you said, this can't be a sudden chaotic overhaul. It needs to be managed, iterative.
Absolutely. It must be phased to avoid disruption. The process generally outlined involves 5 clear stages for transforming a facility. Step 1 is that crucial diagnosis of the current state. A really rigorous assessment to pinpoint the specific losses, the waste, and maybe most importantly, identify those critical blind spots where the facility is suffering from a lack of real-time visibility.
Find the pain points first.
Exactly. Then, step 2 is you have to collect the real-time structured data. This means deploying the necessary IoT layer sensors connectivity to fuel the system. Like we said, garbage in, garbage out. If the data input isn't solid, the whole thing falls apart.
Right, data first.
Them. Step 3 is modeling the facility. This is where you create that high-fidelity digital twin we talked about. You build the virtual representation that accurately mirrors the physical reality. This establishes your risk-free simulation environment.
Okay, model built. Now you can start using the intelligence.
Which brings us to step 4, simulating improvement scenarios within that digital twin. This is where you leverage AI and simulation tools to test potential changes, maybe new production schedules, different machine logic, alternative material flow paths. You analyze their specific quantified impact on key metrics like OEE, cost, throughput, before you actually deploy them in the real world.
Test before you invest.
Precisely. And then finally, step 5 is the actual phased implementation and measuring results. You roll out the validated improvements step by step, maybe line by line or department by department, and you continuously measure the impact to ensure you're getting the expected benefits, making adjustments as needed. It's about continuous, measurable evolution, not destructive revolution.
That roadmap sounds strategically solid. But let's be honest, technology projects, especially big ones like this, often get derailed by the human element, don't they? What are the major organizational or cultural hurdles that companies consistently bump up against when they try to execute this kind of plan?
Oh, absolutely. The sources are pretty much unanimous on this. Dealing with the organizational culture change is often the single toughest, most time-consuming part of the entire process. The number one hurdle is usually organizational resistance.
Fear of change.
A lot of it, yes. It stems from various places, sometimes fear of job displacement due to automation, sometimes a feeling of being watched or micromanaged because of the new data transparency. And often there's just deep-seated inertia. You have operators who relied on their gut feel and decades of experience, and now they're being asked to trust recommendations coming from a system, from data. That shift in authority from human intuition to system-driven insight can be really unsettling for people.
Yeah, you're fundamentally changing how people have worked for years, maybe decades. That's never easy. What about the technical side, the data itself?
That's the second major hurdle, data readiness. We really can't stress this enough. You absolutely have to invest time and effort in cleaning up and organizing your legacy data. So many facilities have years, maybe decades of what's sometimes called dark data.
Dark data.
Yeah, information that's unstructured, incomplete, maybe inaccurate, often trapped in old siloed systems or even spreadsheets on someone's hard drive. If your underlying data is messy, inconsistent, or locked away, the fancy new technology on top simply cannot function effectively. You have to do the hard work up front on data governance, data cleaning, structuring those data streams so machines can actually use them reliably.
Okay, so resistance to change, getting the data right. What's the third big challenge?
It's addressing the competence gap. You need people who can actually use these new tools and understand the insights they provide. Facilities have to be proactive about tackling insufficient digital competencies within their existing teams.
Training them.
Training is a big part of it, yes, focused training, maybe reskilling programs, but it's also about fostering a shift in mindset, encouraging people to become more data literate, to see themselves as problem solvers using data rather than just relying on the old ways of manual troubleshooting. And of course, the tools themselves need to be designed to be as intuitive as possible to lower that barrier to adoption.
Okay, let's pivot slightly. Assuming you're navigating these hurdles, let's talk about some specific tools that can help during the execution phase, particularly around automation procurement and logistics improvements, which can be notoriously slow processes. Our sources mention something about an intelligent marketplace.
Yes, this is a really interesting development aimed at speeding up that whole automation acquisition cycle. Think about the traditional process for getting complex industrial automation, say a new robotic cell or an automated storage system.
Okay.
From the initial assessment of needs, selecting the right technology, finding a suitable system integrator who can put it all together, negotiating contracts, the actual deployment, and then the final optimization. The average time for that whole cycle is around 25 months.
25 months, over 2 years.
Over 2 years, exactly. That's a huge amount of time where you're not getting the benefit of the automation, a massive drag on competitiveness.
So how does this marketplace idea help?
Well, the concept of an integrated platform marketplace tries to collapse that timeline. It acts as a central hub connecting companies looking for automation with a network of pre-vetted, performance-rated suppliers and integrators. But crucially, it leverages the company's own data, potentially from their digital twin model, and uses AI to run simulated cost-benefit analyses and recommend specific solutions or partners based on their actual needs and facility constraints.
So it uses the company's own digital model to streamline the selection.
Exactly. And the results. The claim is that this kind of marketplace environment can effectively halve the deployment time, drastically cutting down that 25-month cycle, and potentially save companies up to 30% on the costs associated with the purchase and initial implementation phase.
How does it save the cost?
The savings come mainly from providing much better data and more accurate ROI analysis much earlier in the process. It helps simulate integration challenges upfront, streamlines the vendor selection, and reduces a lot of the back-and-forth negotiation and guesswork.
Interesting. Okay, let's circle back for a moment to the absolute foundation of all this, that IoT data collection system. For senior managers, for executives trying to grasp the core value proposition, what are the absolute must-know benefits of getting this real-time data collection right? Maybe the top 5 points.
Okay. Top 5 imperatives for management regarding real-time data collection. First, a dramatic increase in data accuracy. Compared to any manual tracking or periodic sampling, it's just far more precise.
Right, no more guesswork.
Second, a massive reduction in analysis time. Managers aren't waiting days for someone to compile a report. They're looking at live, often pre-analyzed, dashboards showing what's happening now.
Instant insights.
Third, it significantly lowers the actual administrative costs associated with obtaining information. Less manual effort, less report generation.
Okay.
Fourth, it enables vastly better operational management because you can finally see the whole picture, all the interdependencies, the bottlenecks forming, the flow across the entire system simultaneously.
Holistic view.
And the fifth, and arguably the most crucial point strategically, it leads directly to faster and more accurate decision-making, which, as we've said, is the absolute core capability needed for adapting and thriving in today's market.
Makes sense. Now, one final critical stakeholder group. The financial leaders,
Right.
the CFOs. They're the ones who ultimately have to sign off on these often complex, multi-million-dollar technology investments. Does this integrated platform environment offer specific tools tailored for financial transparency and justifying the ROI?
It absolutely has to. You won't get any major transformation project funded without solid financial oversight and justification. So a mature platform must include dedicated tools for financial transparency.
What do those tools provide?
They give CFOs full itemized visibility into the expected and actual costs of automation projects. They support detailed return on investment or ROI analysis, crucially linking the projected financial benefits directly back to the improvements simulated in the digital twin. They also assist with comprehensive budget planning and can even help build the business case needed to acquire financing for the transformation. Essentially, the system should be able to accurately forecast the total cost of implementation and, based on those validated simulations of future gains, provide the hard data needed to justify the investment and secure the necessary budget.
Okay, looking beyond the implementation challenges and tools, let's talk about the end game. What's the ultimate vision for the future facility enabled by this integrated intelligence? What does it really look like in operation?
Well, the future of manufacturing, as envisioned through this lens, it isn't just about having more robots moving things around or simply cranking up the volume of automation. It's really about creating these intelligent, self-learning systems that actively collaborate with the human workforce.
Collaboration, not just replacement.
Exactly. The idea is that the system handles the continuous, really granular optimization tasks, the real-time prediction of issues, the automatic adjustments, the prescriptive actions, freeing up the human workers to step away from that constant repetitive monitoring and firefighting.
So humans focus on higher-level tasks.
Precisely. They can focus on more complex decision-making, investigating strategic anomalies, the system flags, driving creative process improvements, managing exceptions tasks that require human ingenuity and judgment.
Now, our sources seem to really emphasize that the biggest transformation isn't purely technological.
No, it's not just about the tech itself. The most profound, the most fundamental transformation is enhancing the organization's inherent capacity for continuous systemic adaptation.
That word again, adaptation.
It's key. The integrated technology platform, the IoT, the digital twin, the AI, they are the enablers, the accelerators. But the ultimate strategic goal, the destination, is achieving that state of constant adaptability. Companies that truly master this combination of advanced data analysis and digitally managed processes, they simply make decisions faster. They make better decisions. They minimize systemic risks far more effectively. And as a result, they gain decisive market share.
So this capability, it's more than just operational efficiency.
Oh, much more. It becomes a core strategic capability. It's about long-term survival, frankly. It's about having the built-in resilience and agility to grow aggressively, even when the global economic landscape is uncertain and unpredictable.
Okay, let's quickly recap some of the specific areas within the operation where this integrated approach really ensures superior flow and efficiency. Where does it make the biggest difference on a practical level?
Well, the synergy of these technologies optimizes several critical flow elements. Firstly, you get true optimization of material flow. Through constant, precise measurement via IoT and analysis, you can ensure materials move smoothly and efficiently through both production and logistics processes. Plus, you get continuous operational efficiency analysis, always knowing where things stand.
And the digital twin plays a big role in planning improvements to that flow, right?
Absolutely. The use of the digital twin for rapid simulation of improvement scenarios is fundamental. It's how you reduce potential downtime related to changes and how you accelerate order fulfillment. You can virtually test, say, relocating a piece of equipment or changing the logic for how AGVs route materials, and you know exactly what the impact will be on throughput or lead times before you commit any real-world resources.
Test, validate, then implement. And finally, keeping an eye on performance across the entire system.
Yes. That's achieved through continuous performance monitoring and the identification of bottlenecks using integrated analytical tools. This goes beyond simple dashboards. It includes applying advanced concepts digitally, like value stream mapping or VSM.
VSM being the process of mapping out where value is added and where waste occurs.
Exactly. But traditional VSM is often a static manual exercise done periodically. The digital version uses the real-time data and the process model to dynamically analyze where value is being lost, where inventory is building up unnecessarily, where constraints are emerging right now. It ensures the entire system is continuously tuned for peak efficiency based on live data, not on diagrams that might be weeks or months old. Hashtag outro.
Well, this has certainly been a necessary and really deep dive into the architecture that's reshaping modern industry. We've explored how bringing together IoT for the data, the digital twin for that risk-free simulation playground, and AI for the real-time intelligence. How that combination fundamentally shifts the entire game.
It really does. It moves the focus away from just managing production reactively, fixing yesterday's problems,
Towards building organizations that are genuinely future-ready. Organizations that are adaptive, resilient, and ultimately far more effective.
Because the limits of that traditional reactive approach are just so clear now, aren't they? When you're constantly relying on delayed reports, on manual planning cycles, you're essentially always giving away time and money to your competitors who can move faster.
So the solution really lies in creating this unified, intelligent system. A system that ensures every decision, whether it's a tiny adjustment on a machine or a massive capital investment, is informed by a real-time, simulated understanding of its likely future consequences.
That's the goal, verified foresight.
Okay, so maybe we leave you, the listener, with this final thought to reflect on. If we know traditional production always reacted with that dangerous, costly delay, just think about the immense untapped potential that still exists in optimizing really complex, high-stakes industrial processes.
Things like managing multi-year capital projects, maybe, or ensuring true resilience deep within your global supply chain.
Imagine tackling those challenges when every variable, every potential outcome, every ripple effect can be instantly visible and simulated beforehand in a dynamic digital twin of your reality.
And consider this. How much of your current organizational risk simply evaporates when your enterprise gains the ability to truly see the full consequences of any proposed change, the cost impact, the operational disruption, potential market risks, even the downstream material requirements before you move a single machine or deploy a single line of new code to the factory floor.
That level of verified foresight, it isn't just about efficiency anymore, is it?
No, it's the ultimate competitive advantage. And increasingly, it feels like a prerequisite for long-term survival and success.
Definitely something to mull over. Thank you for joining us on The Deep Dive.